Welcome to the Modern Application Development to Screencast. In this screencast, we'll see how to set up Celery jobs and make it work with Flask. You will need Linux environment to run this Celery jobs. You will need to install and run Redis. We're going to use them as a message broker. Now, why do we need asynchronous job like Celery jobs? Generally, when you have a large system, you will need a way to run async jobs. These jobs can be triggered by the user through an API or a web request. For example, exporting something or importing a large file, etc., which can't be done at the user's request in synchronization, because it will time out or it will just hang the web server. So you usually trigger a job to process that and then return back or respond when the job is complete. Or there could be jobs that have to start at a specific time and do specific tasks. For example, sending reports or sending status updates at the end of the day, things like that, which start at a specific time and work asynchronously. They don't run on the web server, even though it could be triggered by web server if required. Right. Now let's see how do we go with building such a system. Right. Let's start with a system that helps us to run jobs. We're going to use something called Celery. It's a package and a framework in Python that's flexible and distributed, that allows us to run jobs and workers separate from the web server. The way it is organized is actually quite simple. Now let's take, you have a, like if you take the whole, this is a Celery system, right? You have a message broker or a queue. Okay. And then there will be results backend. I'll tell you when it gets used. Results backend. And there are one or more workers. Workers are the one who will do all your job. There can be more than one worker, like based on the number of CPUs in the system, and they can spread across too. So when a request comes, let's say this is your Flask app, and then let's say there is a user here, right? And then when the request comes, it passes through the web app and triggers a message into a message broker. It gets queued in the message broker, right? There could be more than one request, coming simultaneously. Let's say if there were 4 requests by 4 users simultaneously, it gets queued in the message broker. Then each one of them is taken up by the worker one at a time, right? So first 2 will run and then next 2 will run depending on which one is free, right? And once the task is complete, result is put into result database or result backend, right? And then this is accessed by this system, right? Like that, right? This whole thing works asynchronously, right? So this is your trigger. You either can fire and forget, or you can wait for it to respond back. You can do all sorts of things that we'll see. This is how the whole system is set up. This is called workers, which actually do the job. This is called message broker, which queues up the message and triggers the worker. And then there is result backend, right? These workers can also be triggered by time-based thing. So for example, it could be a time-based trigger or a message, and that could trigger a worker, for example, every 10 seconds or every Monday morning, something like that. And then that could trigger and run the thing. Everything runs through message broker because it handles everything. Now we're going to use a Redis as a message broker because we know that Redis can act as message broker. Now we're going to use Redis also as the results backend because Redis is also a database. We're going to use that also as a backend. We can use different databases. This could be /1, this could be /2, or vice versa. It doesn't matter, right? So this is how the whole system will work. Now we are going to set this up and create some tasks, create some workers, run them, okay, and see how it works. We'll try both user triggered as well as time based. Okay, let's go back to Celery's getting started page. We need to install a package with Redis support, right? So for which we need to install Celery package and Redis package. Redis package is for connecting to Redis database. Make sure you have already started the Redis and connected to Redis in your Redis app, just to make sure everything is working, so that it's set up, right? Okay, now I've already run local setup, so it's kind of install all the packages etc in the env, so it's ready to run like with Celery. So let's add other things to it because we need to set up the Celery. So setting up the Celery is actually quite straightforward, which is similar to setting up any other systems in Flask. Let's go to our main. So similar to our adding adding other modules, we need to add the Celery one. Before we start, similar to our database, we'll create another module and let's set up the Celery there. Okay, let's call it workers.py. okay, I'm going to import Celery from Celery and then our Flask app, create a Celery object, right, and then subtask. We are always going to use a task to create the tasks in Celery that can be run asynchronously. Now we can use the task by Celery, but we want to subclass it so that we can send the application context. So you can use in application context inside the task. So what I'm doing is I'm creating a new type of task called context task, which actually extends Celery's built-in task, and then it calls or runs everything inside the task or given context task within app context. It kind of runs within the Flask application context. Now once this is done, we'll go to main and we'll define Celery here. Before we define, we have to import it. We have to import it from our worker, right? Let's import workers just like how we imported our database, similar to that. Okay, now I'll define another variable called Celery because we're going to instantiate and use it after I set up the app APIs. I'm going to set up the Celery now. So I'm going to create the Celery, which is workers.celery, which is this, and then I'm going to set up the configuration with it with the backend and the broker. Both are going to be defined in the app config. Both are going to be Redis. So I told you broker URL and result backend. We already saw this. This is URL to this is called broker URL. Backend is this, right? So we need to define these two in the app config or like config file. Let's add that. Okay, let's go to config, add it here, and I'm going to use the same thing in local environment. So add it here. So localhost 1, database 1 for broker URL, database 2 for result backend, right? Yeah, I mean, I think that's what we thought about also. Okay, so that's configuration is set up. Now we'll do one step to tell use our context task type instead of built-in Celery's task, right? We're going to replace it so that whenever you call Celery.task, it's actually our specific task with the context in it, right? Then I'm just going to return the Celery along with the app and API, right? Push the context and send it. So here along with app API we also get Celery. Right, so that is the whole setup. Once you do your Celery setup, you can write some tasks and you can handle some tasks, right? Writing tasks is very easy. It's just like any other function, but let's create another module called tasks.py. Okay, let's add a simple function into it. Okay, first of all we need to import the Celery. I'm just importing the Celery from our workers, and then let's add one simple task which prints the name when it's triggered, right? So you can see that it's just a function. Just say hello, takes the input name and prints it. To make it a task, you just need to add Celery.task, and it gets auto discovered by our application, right? And then it gets marked as a task, right? Okay, so let's go back and see whether we have done all the settings. First, let's start with config. We set up the broker URL, result backend. Workers, we set up the Celery, and we set up our new class. Okay, in main we imported the workers, created a new variable called Celery, updated its conf with broker URL and result backend, then replace Celery's.task with our own task class, and then returning that Celery, right? Okay, now we need to start the Celery workers, right? That's to, like, when you trigger it, actually you're going to run this function on a separate process called workers. So let's write a function in bash to start the workers, similar to our local run. So I'm going to make a copy of this first. Okay, local, let me call it workers. Okay, everything remains same except this, right? We are going to call Celery's workers here. That's done by passing the application path, application name. I mean, what I meant is Celery application, and calling the worker subcommand of the Celery. Here actually we are calling Celery worker subcommand and passing the main Celery object that we have, and I'm enabling the debugging with info, right? Okay, so this should start a number of workers. Usually it starts the number of workers equal to number of CPUs in the machine, or number of available CPUs in the machine. So if there are 4 available, 3 available, it will use all 3 or 2, or based on how much our CPUs are available. Just going to correct the spelling here. Okay. And then we have the task, but we are not calling the task yet, right? We have to call the task when the user calls that task, right? Let's see. We have the task here. We are not calling from this task from anywhere. It can't automatically get triggered. So let's write a route in the Flask application to call that, right? Let's go to our controller, and similar to like or feedback, let's write a hello, right? Let's call this hello, and this is hello. Now we have to call the task here. So let's say when the user says hello, we have to call that task here, right? So it's straightforward, easy to call. Something called by using something called apply async. Let's see how it's done. Okay, it's done by importing the task first. Let's import the task. Okay, now we have imported the tasks. Now we'll call that one. Okay, tasks dot our what was our task? Just say hello. Just say hello dot delay. Right? We are not going to put any delay. We're going to call immediately. So we're going to pass the value, and what value we pass is the whatever the input parameters that we are going to pass. We're going to pass the same thing here, right? Let's say Thejesh. It could even be taken from here, right? Taken from, let's say, if I had a similar input attribute, we could do that. Let's do that only. Right, and then we can read it and pass it, right? User name. Okay, now this will return a job. Job and not the response. We'll see how to get the response here, but it will return the job. So I'm going to return that job ID or job identifier along with 200. That just to show it's been started, right? Okay, that's done. Let's see. Let's start the Flask first. I'm already there. Okay, sh local run. Okay, our Flask app is running. Let's just check. Okay, it's running. Now let's start some workers. New tab. Just make sure our Redis is running. It is running. You can see there are many databases and it's connected. Okay. sh local workers. It should start number of workers now. Okay. Here you can see the details it prints. So it is running Celery on this machine. The name of my machine is Uma, and the Celery version is this. It prints the operating system details. then it prints other details like what is the application. You can see this application jobs, which is all Celery app name. If you go to workers, you can see here that one. And then transport is where our messages are put, which is message broker, database 1 on Redis. Results is results backend, database 2. There are 4 tasks, right? There are 4 tasks because I have made 4 CPUs available for this to run, right? Now it's ready, ready to accept the jobs to to run. You can also see that it has automatically pass all the tasks and as listed here. So it's ready to run this job, right? Now let's trigger that job. That job is triggered by calling what was the URL? Hello / username. Hello / let's say Thejesh was the username. Okay, you can see the job ID has been printed here. That's what we were returning, which means the job has been triggered successfully. And now if I go here to my workers, you can see in my workers console the job ID, right? It's the same thing. 49 ends with D9, ends with D9. And then inside the task, hello Thejesh GN, it's run by the worker number 4 and just finished. There's nothing to return. I don't think we are returning anything. We could we could also return something. Let's say we'll do that next. Okay, so here you can see this was our results backend. There'll be somewhere that result that we just ran D9 here. There's no result, let's get the result. Let's say first let's return something. Return same thing. Let's return the same thing with hello. Okay, after printing it will return the same thing. Now in the controller, if you really want to wait till the job is complete and you want to return something to the user, you could return it asynchronously. That would have been better, but I'm just going to show how to do it just for knowing, because it's not really useful, right? If you're just going to wait, I know it is running on a separate machine, but it's usually you will just return 200 and then respond back later, but it's fine. We can just do job ID and job.get. Get will return the response, or wait rather. We can do job dot wait. There will be the result, and we can return the result. Right, let's start the workers again, because we have changed the task. Start the Flask also again. Starting. Okay, so now if I trigger, you can see it has written hello Thejesh GN. Basically from the Flask, the job got triggered, it got run by worker number 4 in the pool, and then it returned the value, and then response came back, and then it got returned to the end user. So this is how you actually call the job. Now delay is a shortcut there is to a function called apply async, right? You could have called apply async, and apply async has many more features. Instead of delay, we can call apply async, right? Apply async has, like I said, many features. You can send, for example, countdown. You can send, let's just remove this and do countdown. I'll just remove this name. I'll just print some date. I'll just create another job, uh, which is much more user friendly for us to check, right? Let's create a job which prints current time on the task, right? So it prints start, then gets the time, prints the time, and marks it complete, right? Okay, now we can call this asynchronously, right? I also want to print before, so that you know the time before it gets called, triggered, and then when it gets called, right? Just it may not be ideal way to check it, but in this case it will work because we are the only one who are putting request, so there is no issues with the ordering or any of that. Okay, now in Flask, right? Now in task. Okay, let's print that also. Okay, so it should print the date time, then 10 seconds later, this is in seconds, 10 seconds later it should call apply async, then it should get the result and return the result too. Let's return also the date time string. Okay, I'm going to remove this, call just hello, right? So what we're doing, we are getting a current time, waiting for printing it, waiting for 10 seconds, printing the same thing on the task side, and then returning the same thing, right? Okay, let's see how it works. Okay, let's start local run. Let's start our job. Okay, so it is scanned, it's ready. Okay, this is also ready. Okay, I'm going to remove this since it's just that. Okay, there's some type error, username. This is not required. Okay, it got called. You can see in Flask now 2022 0 to 17 136.26, right? 136.26, and it has written now, I think, yeah, 136.36. You can see it got triggered at 136.26, but then it went into the task only at the 36, right? Because that's because of the countdown, 10 seconds. It's just telling start after 10 seconds. And there are many other parameters. Let's check couple more. Just we're not going to cover everything, but we're going to see some. We can also say, for example, start now but expire in 2 minutes, or expire now or in 2 days. For example, you can do this, right? count for 60 seconds and expire in 120 seconds. If it doesn't work, if the task checks more than that, then just expire the task. You can do that. And then you can also send ETA. For example, you can say instead of 10 seconds directly, I could have done this ETA now plus time delta 10 seconds. This is useful if you want to do like yesterday plus something, all that kind of thing. Basically, when the time becomes equal to ETA, then it just runs, right? So this is also same as 10 seconds, like when it runs in the next 10 seconds. So you can do all of this with apply async. We already saw how to get the result by waiting. This is similar to async jobs that you would do in any async job. Okay, now let's assume that there is no user call like this, but instead we want to call that every 10 seconds, like a timed. So there is no this, so there is no user trigger, but we want to trigger this every 10 seconds, right? Call this every 10 seconds or every second, whatever that we want to call at some scheduled time, for which we need to set up a scheduler, right? I'm just going to convert this into like a scheduled job, right? So first I'm going to import Crontab. Crontab is a scheduler. Even otherwise you could find it in a Linux or any Unix system. We're going to use similar Crontab here. Now once the Celery scans for all the tasks and finalizes it, we are going to schedule it. We are going to create like a function which schedules it and which gets called on after finalize. On after finalize gets called, a function tagged on after finalize gets called after the Celery app is set up. It scans for all the tasks and prints it and stuff. Then we're going to schedule it. You can just set this up here, and name I'm giving is at every 10 seconds, and that value is given here. You can print you can call this function. This is the signature of this function, right? And it should run. Let's run. I'm going to show you what are the other kind of setups you can do using cron, but let's start with this. Now actually you don't need Flask app at all, because it should run automatically for every 10 seconds. Let's clear this. It doesn't matter whether Flask is running or not. Let's run it anyway, right? Instead of, okay, let it run for every 10 seconds. So it's set up now. Print current job is set up. Now it's not running, right? It should have triggered by now. It's almost 10 seconds. That's because we had to set up a timer or something called Celery beat, right? Celery beat is going to be another task or a worker that you will run separately, so that it can keep track of time and schedule things, right? We can do that by running the command Celery, similar to how we started workers. Will start beat, but I'm going to create a bash script for that. Okay, let's go back here. I'm going to stop this first, because anyway it's not working, because we have not set up the beat. Okay, I'm going to set up new file, Celery beat. Okay, I'm going to set up Celery beat for this Celery app. That's it. I'm just logging, and maximum interval is 1 second. So it runs, checks every 1 second, right? Now I'm going to open another tab, start Celery beat first. local beat. Let's see whether it's running. Yes, it's connected to the broker, loading, and it's running, right? Okay, it's scheduling. You can check, no, Celery beat schedule. Sending task due to every 10 seconds, but the job is not running. It's already sent one, but job is not running. So now the job is running. It's as soon as it opened, it picked up because this is already scheduled. See, it's scheduled another one. It'll pick up another one. We are not even running the Flask at this point because Flask is not in picture currently. Right? So this is how you run the scheduled jobs. Right? Now instead of 10 second, you can say every 24 hours and many other things. Right? Let's go to task instead of this. You can do many other types of scheduling. Let's go back to check the details of this setup. Right? So it can take various kinds of values. The most important is Crontab, which you can set up many ways to call this on specific things. For example, you can even say day of the week is actually which day, Monday or something like that. We can set up many things. Currently this one actually this runs Monday 7 a.m. 7:30 a.m. right? You can set up various things. You can check up Crontab Guru to see what all you can set up. You can set up monthly, yearly, daily at certain specific time, all of that, right? You can create a cron tab and set up everything. I've just imported the cron tab. I've not used it. If you want, because I directly gave the value, but I could have created a cron tab and then set up specific values to run this task. So that's how you actually schedule the periodic task. Like for example, if you want to send a report every day, you would just say 17 p.m. 17:00. That's it. You don't need to give day of the week, and that would schedule every day at 17:00 hours or 17 hours. So that it runs at 5 p.m. every day. That's how you schedule periodic job. Now you can also be interested in how the data gets passed from Flask or any other place into Celery queue. It's usually whatever let's go back to see whatever values you pass. For example, if you were passing your username here, usually it will get created, converted into JSON and posted, and then it receives the JSON and parses and calls the function. So JSON is a serializer format. So indirectly you can always post a JSON and then call the job also, and if you want to call it directly. Let's take a look at that. Let's say there is another one called like hello world, right? It takes a name. Let's say hello. Okay. Let's start. I'm just going to stop this and mask this for a while. Okay, it doesn't matter. Running Celery beat now because we have masked the scheduled job. But let's say we are going to run this. Now I want to call, or this is pending from pending messages. Okay, now it's waiting. Now since it's processed all of it, I think, yeah. Okay, now, yeah. So now I want to call this hello world, but directly calling Celery. Then the easiest way would be to use something called Celery call and call the task directly. Call it like this. I'm calling Celery call on this object of Celery, and then I'm calling this task. Task is hello world, right? Yeah, and passing the arguments name is equal to Tej. So it should print hello Tej here, right? Here got called. This is how you call a Celery task from any other place. Like if you have normal scripts running, or normal shell script, or in some other third party, any other language, all of that can call a Celery job directly by passing the task name and then passing the arguments as a JSON. Okay, now one more thing that I wanted to show was a chaining and link backs. I would leave that to your own explanation. They are quite an interesting things to do. Chaining is, if an addition, you can pass the response of one function, one task to another task. Let's say Celery. Okay. Chains. For example, if you had an addition function or a multiplication function, for example, add function, then after adding these two, you want to call a multiplication function by passing 4 along with 16, then you would get that, right? So here you can see that we are calling add, passing 2 and 2, and then linking it to mul.s. This is so then when you get the result, it's actually wrong. It should be mul.4.16. Mul here is multiplication, then it should be multiplied, not divided, right? Result, the link task will be applied with the result of its parent task with the first argument. In the above case, result was 4, so the result in mul 4 cross 6 4 comma 16. So I think it should be multiplication of these two should be the answer. Let's say there is another easier example to look at. Okay, here import celery.chain, and you have two tasks, one called add and one called multiplication. So you want to do 4 plus 4 star 8 star 10. Instead of one call, like for example, you could have done this separately, right? You have to call get at every time. Let's say you had R1, then let's say this is task 1, then R1 is equal to T1 dot get, then you pass this result here, right, to multiply, then you get R2 get or wait, you can do get, and then you continue like that, right? So instead of that, you can chain them directly. So here the result of this will be passed to this, and the result of this will be passed to this. So hence it becomes like this. So this is one of the very useful ability of Celery tasks, where you can chain tasks. This will give you an advantage where you have multiple steps to do something. Then you can chain one by one. In some cases, if you want to call only one, you can call one of them directly. Yeah, chaining is a very useful function when you have a longer workflow, when you have multiple tasks that needs to be called sequentially or in some order by passing the result of the first one to the next one. Or in some cases, you might call second or the third step directly. For example, if you have get the list of users, then send email to users. And sometimes you want to get the set of users and then send emails to users. But sometimes you might already have this set of users, then you will call directly send emails to users. So in that kind of scenarios, chaining becomes really useful. Right. Another functionality that I wanted to show was callbacks. Callback is actually once the task is done, call another task. Right. We have already seen once the addition is done, call multiplication. We saw one example here. Some add is equal to yes or okay, not this. Yeah, here. So this is first you add these two and then you add another one, right? So you can do one level of linking, but chaining is like multiples of it. There are many other features that you can have a look at it, like grouping and mapping, etc., etc. I will leave those to explore to yourself. So what we have learned today is how to set up Celery, how to configure Celery with Flask, how to write a task, how to call a task from Flask on user's request, how to get the result, how to get the job ID, and then if you don't want to call it from Flask, you want to call it on a time, how to set up the cron and call it on scheduled times, and then if you want to externally or manually call the task directly, how to pass the JSON and call them directly. These are the features that are basic features of Celery that you would use every day. And I hope you will end up using Celery to a great success and offload your work from the main web service into Workers. That's it for today. Thank you for watching.